Okay, here we have the start of a new unit. The first thing that I want you to do is I want you to look here at this picture and make a prediction. What do you think this unit will be about? This is question one in your notes. So over here, write in your prediction. What do you think this unit is going to be about based on this picture right here? So pause and answer the question. Okay, next we have our pre-assessment. If you look here in the notes, you can click on this and it'll take you to Amplify. You need to log in. You need to complete all three parts of the pre-assessment. So the multiple choice and the two short answers. The pre-assessment will be for a completion grade, and then later on you'll take the same assessment as the post-assessment, and that will be for an accuracy grade. So as you're going through these questions, pay close attention to them. You might not know the answer yet, but keep in mind, you'll be asked the question again at the end of the unit. Okay, hopefully you've now paused and done the pre-assessment, and we are moving on to question 3 in our notes, which is the warm-up. So the question here says, what are some ways that sunlight causes changes here on Earth? The sun does cause changes here on Earth. Think of examples of how sunlight changes various objects here on Earth. If you're having trouble starting with your brainstorming about how it changes, look back at the prediction for question 1 and this picture up here. That might be a clue as to one of the changes that the sun can cause. So try to come up with a list of 5. All right, question 4 in our note says, write the unit essential question here. So our overall essential question for the whole unit is, how does light interact with materials? So we're going to be trying to answer this question over the next 4 to 6 weeks. Copy this down in your notes, please. Okay, in this unit, you will take on the role of student spectroscopists, scientists who study light and how it interacts with materials. Now we'll hear from Dr. Whitmore, this woman right here, a real spectroscopist. As you watch the video, get ready to answer question 5 in your notes. What are your reactions to the video? And do you have any questions about it? I'll go ahead and go full screen and show the video.
I'm Dr. Desiree Whitmore, and I'm a spectroscopist and a professor at Irvine Valley College in California, where I teach about light and the devices and technology that use it. Light carries energy with it from one place to another. As a spectroscopist, I study how that energy interacts with different materials. One way that you might be familiar with is the way that light can be used to warm things up. For instance, here at the beach, I'm surrounded by sand, and this sand can get very warm from the sun. So if I take my shoes off, I might burn my feet because it's really hot. Another example you might be familiar with is people at the beach laying out to get warmth from the sun. Well, unfortunately for me as a spectroscopist, I can't just sit out in the sun all day to study light. I've actually got to go into a lab to see how light interacts with different materials. So now we're going to make white light, so I need you to install this blue laser.
Okay.
So here you can see the blue laser. In my lab, I use a special technology called a laser, which generates a concentrated beam of light. I use the lasers to study how light affects different materials. Even our bodies and objects around us emit light. This is a special camera that can detect that light. So now this camera is measuring the light that is coming off of my body. On the screen, you can see red represents warmer temperatures and blue represents colder temperatures. I can also use light to study gases. Here I have 3 different tubes filled with gas. When I run electricity through these tubes, light gets put out. Similar to a neon light that you would see in a store, except these are different gases. One way that I study the gas is to use a special tool called a diffraction grating. When I look through the diffraction grating, I can see the light from the gas tube being split up into its different components, and that gives me more evidence about the material in the tube. One of the great things about light is that it's all around us. Everywhere you look, you can think about the science of light. Light and the technologies that use it are exciting fields of study. We need more light scientists to join the field and carry us into the future with new and innovative technologies.
All right, go ahead and answer question 5 here in your notes. What are your reactions to the video? Do you have any questions about it?